So let's start. Let's see this video in the beginning.
Narrow body aircraft. Hey, I had him some shake.
You can hear the sound?
Sounds smart. I bet my last road.
Yes, we can.
It's a fleet-powered aircraft. A leap into the unknown. Something you haven't seen before. Everybody get ready. They're going in.
Okay. So we will continue. So last time we have seen this turbofan engine, and we have recognized two kinds of flow. We have the primary flow, which is passing through the core engine, and there is also secondary flow, which is passed through the fan. Okay, and the ratio of the secondary air flux to the primary air flux, we call it bypass ratio. Bypass ratio. So the larger this value is, the higher thrust you will get, and also more fuel efficiency. Okay, so we are going to go inside to investigate the remaining parts. Actually, last time we have finished, I think, the fan, right? And now we should go to the compressor. We have finished this part. If you have any question, let me know. Otherwise, we'll move to the compressor. Okay. So in the compressor, we are going to know what is the function of the compressor, and we'll see the increment of the pressure and temperature. So in the compressor, its name is compressor, so the pressure will be increased, and at the same time, the temperature also will be increased, despite the fact that we are not adding any kind of heat energy here. This is a feature of the gas or of the air. When you compress it, the pressure will increase and the temperature will be increased as well. And then you are going to take a picture for one of the compressor stages and label the rotor and the stator. So the compressor is consists of several stages. عندنا فيه كم stages كم مرحلة يعني. So each stage is consists of rotor. Rotor, what does it mean? Something which is rotate, يعني moving part. And there is a stator. Stator is coming from state. That's mean it's remaining stationary. So there is a moving part and there is non-moving part. So you are going to take a picture and labeling which part is moving and which part is rotating. Okay, so let's investigate the compressor. And as you can see here, we have the first part of the compressor is separated from the second part of the compressor. There is actually two spools. So there is low pressure compressor, and then there is high pressure compressor. Okay. Right. Let's investigate it. So this is the function. They gradually increase air temperature and pressure. So both will be increased in the compressor. It will increase the temperature and the pressure to the right level for combustion. Because after the compressor, the gases will leave, or the air will leave to the combustion chamber. And there it will be burned out. So we are preparing the air to the next stage to have a higher efficiency, higher, let's say, heat energy efficiency. Okay? So let's see how we can simulate this. So it asks me to press the pump all the way down to increase the air and temperature. This is to just, of course, on the right side here, what you are seeing, this is not the exact thing which is happening, but this is just a simulation. This is to show you how we are pressing the air. Okay? So I'm going to move this up and down. So you can see that there is one part which is rotating, right? Which is this part. This is what we call it rotor. And there are stationary parts, which are these 1, 2, 3, 4. So this is call it stator. Okay, so rotor and stator. You can see my mouse, right? You can see the mouse?
Yes, sir.
Okay, hello. So again, I'm going to compress the air. And you can notice that the air has left the first spool going to the high pressure compressor. So we start with low, then we are going to the high pressure compressor. And you can even see the air pressure indicator and temperature here. It is increasing. And even the color of the flow has been changed from blue to yellow. And this is indicating an increment in both temperature and compression. Okay? So I will keep pressing the air until it gets to the last stage. So as you can see again, as we compress the air, the flow color is changed. Similarly, the temperature is changed. So after you apply the needed pressure for the combustion chamber, then it will the engine actually in the combustion chamber. This is what we are going to see later. It will start burning this the mixture of the compressed air with the fuel, and then it will ignite the mixture. Okay? Do you have any question here? You can refer to the video later on if you didn't do so now. You can refer to the video to have a picture for the compressor stages and label rotor and stator. So no more information needed here. We can investigate this, the compressor. The compressor comprises several stages of rotating blades, here rotor, and stationary guide vanes, stator, okay? That compress the air coming from the fan. So the air coming from the fan, it will be sucked by the fan, and then the compressor will be compressing it. In simple terms, the rotor processes the air against the stator, increasing air pressure and the temperature. So there is a stationary part, and there is moving part. So the moving part will it will move, or it will process the air against the stator, and this will increase pressure and temperature. Higher air temperature and pressure is required for efficient combustion. So why we need to increase the air pressure and temperature to have efficient combustion. Okay? And also there is the blade design. You can see here the air is compressed more efficiently in this new generation engine thanks to the latest 3D aerodynamic designed blade. So if you want to increase the efficiency of the air of the compressed air, they have designed a very efficient 3D blade. Okay, so again, the compressor, the function is to increase the pressure and temperature to have efficient combustion in the combustion chamber. Okay, the compressor is consisting of several stages. Each stage is consists of rotor and stator, and each rotor and stator is consisting of blade, and this is the design of the blade. So blade, then stator or rotor for assembly, then you have the stage, and then you have the spools. If you have any misunderstanding of these concepts, please let me know. Otherwise, we'll move to the next part. Are you okay? Okay, so we'll go to the next step, and here we'll have the combustor. Before that, let's read the associated questions. So what is the function of the combustor? Inject the fuel to the combustor to start combustion. How do the pilot control the fuel quantity injected to the combustor? So to answer this question, if you remember the second or third lab, when we were in the lab using the flight simulator, we have seen the control lever or the engine lever or throttle lever. Okay, so by moving the throttle lever upward, this is what we are going to see inside the combustion chamber. So that lever is directly connected the combustion chamber. It will increase the level of the fuel. Okay, it will increase the mass flow rate of the fuel type. And then you are going to take a picture for the combustion chamber showing the fuel flow and the airflow from the compressor. Okay, fuel flow which will come or which will be controlled by the throttle lever, and the airflow is coming actually from the compressor. So you are going to take a picture also. Now let's see the combustor. Type of combustor, we call it annular. You are going to see this later, inshallah, in the coming courses. So after leaving the compressor, so we have left the compressor, okay, and now we are in the combustor. So the air entered the combustor, where the compressed air and jet fuel are mixed together. So you have we have air from the compressor, and there is a fuel line which will bring the fuel from the fuel tank, and then there would be a mixture. Okay, and they burn and generate the energy needed to operate the engine. So this is the function of the combustion chamber. Okay, clear? So let's see it. طيب, from the left, what do we have, بنات? What do we have from the left? What does this represent? Deep sleep. No answer at all? ولا حتى محاولة؟
سير قصدك الكمبرشر شيء؟
Yes, this is the compressed air coming from the left side from the compressor. You can see here, this is the last compressor stage, and where I'm pointing the mouse, this is the rotor, okay, and this is the stator, okay. So the air is coming from the compressor, and as you can see, the color is in red. That means the pressure and the temperature has been increased, and now it's moved through what we call it here diffuser. This is, we call it diffuser, okay. There is a passage from the compressor which link the compressor to the combustion chamber. We call it diffuser, okay. So then the air will come here. This is the combustion chamber. Before that, there is a fuel coming from this fuel line. You can see this fuel line on the top, okay. So this will bring actually the fuel to the compressed air. So they will meet here. They will meet here, okay, and they will be mixed here. And then we in the combustion chamber there is an igniter which will ignite the mixture. يعني عندكم ثلاث حاجات هنا بنات. عندكم air هواء، عندنا fuel. إذا عندي air وعندي fuel حطيت عليهم نار، شو راح يصير؟ احتراق. تمام؟ So this is what happening here in the combustion chamber. Now I'm going to increase the level of the fuel. Okay? I'm doing this right now by my finger. In the actual situation, as we mentioned, we have to, or the pilot will use the throttle lever. You can see as I increase the fuel flow, you can see the combustor here is increasing, and this will increase the thrust. This will increase the thrust. Okay. So, ladies, if you are flying an airplane that you want to increase the speed, what you are going to do? You have to increase the flow, the fuel flow, as I'm doing here. And of course, you are not going to do this by your finger, otherwise it will be burnt out. But you are going to use the throttle lever. Okay, increase the combustion and hence increase the airplane speed. Okay. have any question here? Have you taken the picture? You can have a screenshot. You have to paste it there, showing the fuel and the remaining components. Now we are going to move to the turbine stage. And as you can see here, it is very clear. We have this is the turbine, and it consists of how many stages? Can you identify it? So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 stages of turbine. So what do you think? What are shown here? Are they the stator or rotor? So again, in the turbine, we have also stator and rotor. But what's shown here? Are they the stator or rotor? So since it is linked to the shaft, this is the shaft. Okay, we have two shafts. There is bigger shaft and there is smaller shaft which pass through the bigger shaft. So the assembly which is connected to the shaft it will rotate. So we call it rotor. قناة أي شيء على الشافت طبعا بيدور صح؟ الشافت يوم يدور ايش بيصير؟ It will rotate anything linked to it, including the blades or the rotors. تمام؟ So how many shafts can you identify here? Which pass through another shaft. Now this shaft is connecting what we call high pressure turbine, high pressure turbine. Okay, it will be connected to the high pressure compressor. So there is a shaft linking the high pressure turbine to the high pressure compressor. Okay, so to rotate it. And there is another shaft. How can I change the color? Okay, from here. So I have this one. I'll give it actually a blue color. Blue represent low pressure. So this is sorry guys, actually I have did a mistake here. This is the low pressure. Again, I will repeat it. So this is the shaft which links the low pressure turbine to the low pressure compressor. So it will move there until it link the low pressure turbine to the low pressure compressor. Okay, you can see this shaft. شايفينه يا جماعه ولا انا شايفه براي ما في زول شايفه معي؟ شايفين الشافت هذا؟
Yes.
الحمد لله شفتوه. طيب now I'm going to show you the other shaft which is this one اللي هو أكبر منه. So this shaft, this is the second shaft as you can see here. And this one links this turbine to the high pressure compressor. So this is high pressure turbine. So the one with the red color, this is a shaft. Okay. And it is a hollow shaft. يعني shaft من الداخل مجوف. ليش؟ عشان ال other shaft اللي هو ال inner shaft can go through it. Okay. So the high pressure turbine is linked to the hollow shaft, and from the other part it is linked to the high pressure compressor. So again, we have two spools. That's why we say we have two spools. How we can know we have two spools? If there is one shaft, there is one spool. If there is two shafts, there's two spools. If there is three shafts, there's three spools. Spools means like group. Okay? مجموعة يعني. Okay? So in this turbofan engine, we have two spools, high pressure and low pressure. Okay? So from the turbine ends, you can see that we have the low pressure turbine and the blue color. Okay. And it is connected to the low pressure turbine and to the fan. So this one is connected to the other side. You will find the low pressure compressor and fan. Okay? So these are connected together through this inner shaft. And the high pressure turbine, this one is connected to the high pressure compressor to the outer shaft. Okay, so this is the turbine. Let me see the questions for the turbine. What is the main function of the turbine? Swipe to right to spin the turbine. How many stages does the turbine comprise of? And there are two turbine spools, low pressure turbine and high pressure turbine. Which one drives the fan? Which one of these two spools? I have explained it already. We have the low pressure turbine will drive the fan and the low pressure compressor. High pressure turbine will rotate the high pressure compressor. Okay, take picture for it and the associated driven part listed below and label the part. So it is referring actually to the low pressure compressor and fan and turbine. So let me go back to the application. The turbines are driven by the hot gases from the combustor. It in turn driving the compressors and fan via the turbine shaft. You have seen the shaft. You have to push the air against the blades to make them rotate. Now this is the simulation part. Okay? So as you can see here, the air is coming from the combustor and it's passing through the first stage, and there is a gap between the on the right we have the low pressure turbine, on the left we have these two stages for the high pressure turbine. Okay, so high pressure turbine, low pressure turbine. How many stages? How we can know that? You just need to count this: 1, 2, 3, 4, 5, 6, 7, 8. So these are the number of the stages. These are rotors which I count, and rotor has its own has an stator before it. So this is the first rotor, and there is an stator here before it. There is the second rotor, and there is a stator, and so on. Okay, so I will the air will be expanded through the turbines, and this will, as you can see, move the turbine, which in turn will move the compressor. Okay, so this is the full cycle of the turbofan engine. Now you can see here, what do we have here? This is the low pressure turbine, drives the fan and the low pressure compressor via the turbine shaft. This is the turbine shaft. So low pressure turbine shaft, high pressure compressor. Okay, and this is the second one, which is the high pressure compressor. High pressure turbine and high pressure compressor, and they are linked through the shaft. And this is the whole process, as you can see. Clear? Okay, I think we have answered the questions. What do we have here? And then there is a question here: how did CFM enhance the strength to weight ratio of the turbine? You can see, if we want to learn more, we'll see the ceramic matrix composite. If we went here, the Leap's high pressure turbine includes ceramic matrix composite, which is CMC, an advanced material that considerably reduces weight and can stand up to high temperatures. Okay, so this kind of material reduces the weight and increases the ability of the material to withstand the high temperature. This is cooling system, and there is the ceramic matrix composite for the high pressure compressor will withstand the high temperature. نحن عارفين إنه when the air is coming from the combustion chamber, it came in a very high temperature. So if it hit the turbine and the turbine does not have a material which can withstand this high temperature, then it will be melt out. Okay? So that's why we are using ceramic matrix composite to withstand the high temperature. And there is titanium aluminide. This is for the low pressure turbine. Low pressure turbine is made from titanium aluminide. A new generation allow that reduces engine weight while providing the same performance and strength. So this is the answer for the question. How we have increased the strength to weight ratio. Okay, this is how we have increased it, by using this material, which actually reduce the weight. Okay, and without compromising actually the strength of the material. Okay, again here we have two materials. One, the ceramic matrix composite. This is used for the high pressure turbine because the temperature there is very high, so we have to use a material which can withstand this high temperature. And in the low pressure turbine, which is after the high pressure turbine, they use titanium aluminide. The temperature is not like the high pressure turbine, and that's why we don't use the ceramic matrix composite. And at the same time, we have used the material which is featured as with the high strength and low weight. Okay? Now we'll go to the next and the final step, which is the exhaust. This is where the gases will leave the engine with a very high speed. Okay? So we'll see it. And before that, let's see what are the questions related to this part. What is the main function of the exhaust? Use the throttle to give the engine the right level of power. Describe the power level used in takeoff and cruise flight. And explain how does the engine move the forward an aircraft. I will leave this for you. You can Google it to know how does the engine move the airplane forward, or even we may find it here in this exhaust part. Now let me move back. So the exhaust assembly is especially designed to improve the efficiency of by mixing the primary and secondary airflows. So we have to, as we know, in the turbofan engine, we have two flow. We have the secondary and primary. So the exhaust at the end of the engine will mix these together, the secondary and the primary. But the primary flow creates the energy needed to operate the engine. Okay, so the primary flow will create the energy to move the engine itself. The secondary flow generates most of the thrust needed to move the airplane forward. Okay, it's almost like 90% of the thrust is created by the secondary flow, which is created by the primary flow is to operate the engine, to move the compressor, to move the fan, all these things. This is the primary flow. Okay, right, now let's see. This is the airplane, and this is the, as you can see, the engine connected to it. So this is this you are going to see it in the flight phases in performance. So the first phase of the airplane is taxiing on the runway. After that, the pilot will give full throttle, full power to move the airplane, to let the airplane leave the ground. So we'll give full power, and then when it reaches to the altitude, which we call it the cruise altitude, the engine thrust should be decreased, okay, to a certain level. According to there are many factors like the airplane weight, the number of passengers, all these things, and the density, the altitude. You are going to put the throttle at a certain set. It should not be at the maximum, otherwise you will consume a lot of fuel and even the turbine will not withstand that high power. So now use the throttle to give the engine the right level of power. So if you are going to take off, I have to put it at the maximum. You can see here, I put it at the maximum. So this is the maximum. Okay. Now I have to decrease it when the airplane is in the level flight. As you can see, what should I do? I have to decrease. Watch out, your engine is speed too high. I have to decrease the engine. Okay. And this decrement, as I mentioned, it depends on a lot of factors. The density of the air, the aircraft weight and a lot of other things, and the speed that you want to fly the airplane on. So this is all regarding this. Okay. So there's here, okay, this is the answer for question 8. How does the engine move forward an aircraft? We have seen internally what is happening. Let's zoom out and see what large volume of air and ejected at a very high speed. As you can see here in the front, there's a large amount of air which is go through the engine, and the speed of that air is not too much, and then it will be ejected with a very high speed. So the air will leave, or the gases will be leaving with a very high speed. Okay. Creating a thrust that moves the airplane forward. This is an application of which Newton's law? For every action, there is an equal and opposite reaction. So the action here is the air which is moving backward in a very high speed. Then the reaction would be a force which is equal to that one which is moving backward, which will create the thrust that move the airplane forward. Okay, so this is the answer for the last question. Now